our second to last lesson, which is all about piecewise functions. So you should be on, I think it's page 28. Does it look like that? I'm right? Okay, cool. I'm actually right. All right. So piecewise functions are a little bit weird. They're not complicated, they're just weird because technically they are considered functions, so none of the x values repeat, but it's almost like a puzzle of mixed matched pieces of different functions. All right, so like you'll probably have like a part of a linear graph, then a part of a quadratic, then a part of another linear graph, all with on the same graph. All right. What makes piecewise so special is their domains. So basically, for a certain set of x values, you have this part of the function. For another certain set of x values, you have a different part of a different function. So it's like they cut off functions in different spots. So basically, with piece functions, what in this class, what you really need to know is how to evaluate them. All right. So we've done a lot of evaluating with just normal functions, but now we're going to do it with piecewise. Now, the problem with piecewise and evaluating is that you have to pick the correct piece to use when you're evaluating. All right? Because you can have up to 3 different functions, all in the same graph, but depending on what the x value is and what the domains for those functions are, that would be the one that you use. So, like I just said, piecewise functions is a function with more than one formula used to define the output. All right, meaning there's more than one type of function or different expressions, literally pieces of functions. Each formula has its own domain, and the domain of the function is the union of all the smaller domains. And we notate it like this. So remember, domain is x values. All right. So when you have a piecewise function, you'll have f of x, and then you'll have a list of the formulas. So that can be anything from like 3x plus 1, x squared plus 2, anything like that. All right, that's what I mean by formulas. It's what you would actually think the function is. Then the domains would be the x values where that function is valid. All right, because again, they use different pieces of different functions within the graph. So the way we tell where the pieces start and stop is through those domains. And typically, these domains will be written in inequalities. All right, so you really got to know your inequality symbols. Now, let's actually look at an example, and I'll show you guys kind of how to read this. So look at example 1. So example 1, this is the piecewise function. These are the 3 formulas. And these are the 3 domains. Now, the domain that's directly next to a formula is the domain for that formula. So for example, 5x minus 3 has this domain. X plus 8 is this domain. 1/3 x plus 7 is this domain. All right. So the ones that are directly next to each other are connected. All right. Now, whenever we're evaluating a piecewise function, you always start with the domain. All right. Because essentially the domain is going to tell you which function you're going to plug that number in for x for. All right. So you don't, when we have to reevaluate, you do not plug the number in for all three x's. All right. You're going to only plug it into one of these. Okay. So off to the side, we're going to write a little bit of steps for evaluating piecewise. All right. So the first step is to plug the given x value into each domain and see which statement is true. The second step is to then use the formula connected to the true domain and plug the given x into the formula. And then the last step is to just evaluate. All right, meaning, you do the order of operations, put in your calculator, whatever you need to do. Your answer will be something, it's just be a number. All right. Now, these steps may not make complete sense right now, but we're going to go through each one for each example for number one. All right. All right, everyone go with writing down the steps. Am I good to move on? Need another minute? Okay, give you guys 1 more minute. Good. All right. So let's look at the very first example in part A. So f of 2. That means we're finding when x is equal to what? 2. So remember, f of some number, that means that's our given x value. So we're finding when x is equal to 2. So the very first thing I'm going to do before I start plugging things in and getting an answer, I need to figure out which of these three functions I have to use, because I'm only going to use one of them. All right? The way I do that is by taking this 2 and plugging it into each of the domains. And the inequality that's true, if we say it out loud to ourselves, is the one that we pick. All right? So let's just go through this. If I plug in 2 here, I will have 2 is less than negative 2. Is that a true statement? No. So we don't use the first one. Now, the next one, negative 2 is less than or equal to 2, which is less than 3. Is that a true statement? Yes. So we're probably going to use this. But let's still check the last one. 2 is greater than or equal to 3. Is that a true statement? No. So, since this is the true domain, we're going to use x plus 8 to plug the 2 in. All right? So, since negative 2 is less than or equal to 2, which is less than 3, we're going to plug this into x plus 8. So now we're going to take that 2, plug it in for x, and evaluate. So I have 2 plus 8, which is just what? 10. And that's our answer. All right. So the biggest mistake that I see people make with piecewise, one, they plug it into all three functions. All right. You are only ever going to plug in a piecewise into one function. All right. Within the piecewise. The way you can tell is through the domain. All right. So let's try the second one. So f of negative 4, that means I'm looking for when x is equal to negative 4. So we're going to do the exact same thing that we just did. We're going to take negative 4, plug it in for each of these domains, and then say it out loud. If the statement's true, we use the formula that's connected to it. All right? So, is negative 4 less than negative 2? Yes. So right off the bat, reason the top one. All right? Because negative 2 is not less than or equal to negative 4, so that's automatically out. And then negative 4 is definitely not greater than or equal to 3. So, since negative 4 is less than or equal to negative 2, that means we're going to use 5x minus 3. And then we're just going to plug it in for x. So I'm going to take 5 times negative 4 minus 3. What's 5 times negative 4? Negative 20 minus 3. Negative 23. So that would be my answer. Is this making sense to you guys? It's fairly straightforward. The main issue I see, again, is just you guys forget to plug it into the domain to tell you which function it is. You just think you have to plug it into all three. All right, yes, ma'am. That says less than. Yeah, so I'm basically just restating the domain. Oh, it should have an equal to. My bad. It should just be less than. Yeah. You're good. Thank you for calling me out on that. All right. Let's do one more together, and then I'll let you guys try the other one. All right. So f of 3, that means I'm looking for when x is what? 3. So let's look at our domains. Now, be careful because if you notice, 2 of our domains do contain a 3 in them. All right? It's all going to depend on the sign. Okay? So first off, is 3 less than negative 2? No. So top one out. Is negative 2 less than or equal to 3, which is less than 3? No. Because 3 can't be less than itself. All right? So x plus 8 is out. Is 3 greater than or equal to 3? Yes. So we're going to use the bottom one. All right? So this is one of those where that little tiny line underneath that inequality is very important. Okay? So since 3 is greater than or equal to 3, we're going to use 1/3 x plus 7. So I'm going to plug in 3 for x. What's 1/3 times 3? Just 1. All right? If you think about it, it's just dividing 3 by 3. So it's 1. What's 1 plus 7? 8. And that's our answer. All right, take a minute. Try the fourth part of letter A on your own. So you're finding f of 0. All right, guys, 1 more minute. All right, thumbs up if you're ready. All right. So, first off, let's talk about this. If we plug in 0 into our domains, which function do we end up plugging in 0 for? The second one, so x plus 8, because negative 2 is less than or equal to 0, which is less than 3. That's a true statement. So if we plug in 0 in for x, and x plus 8, what's my answer? 8. That's exactly what I got. All right, so that's exactly what I got. All right, any questions on the evaluation process of piecewise? All right. Now, the 3 linear equations have y-intercepts of -3, 8, and 7, respectively. Yet a function can only have one y-intercept. Remember, the x's can't repeat, and if you have 3 y-intercepts, that means you have 3 places where x is equal to 0. All right? So which of these is the true y-intercept of the function? So let's think about this logically. If you were to write a y-intercept as a point, all right, so think about it. If you're on a graph, that means it's on the y-axis. How would you write that as a point? It'll be 0 and then some number, right? That's how we would write it. So that would be the point for our y-intercept. Now, guys, heads up, come on. So that means we're looking for when x is what? 0. So we're looking for when x is equal to 0. Now, based off of our piecewise function, what domain does 0 fit into? The second one. So if 0 fits in here, So plug in 0 in for x, and what do we get? 8. So our true y-intercept is the point 0.08 because that's where 0 fits into the domain. All right. So our y-intercept is equal to 8 because 0 fits into the second domain. So in other words, it's true that -2 is less than or equal to 0, which is less than 3. All right, so if it ever asks you to find the y-intercept of a piecewise function, you're finding when x is equal to 0. That's what you would put in the domain. All right, does that make sense? Now, we are then going to calculate the average rate of change over the interval -3 x 9. Now, this is a math 1 thing. Average rate of change is math 1 thing. Essentially, we're finding the slope between those two numbers of your graph. So, just for reference, the formula for average rate of change is y2 minus y1 over x2 minus x1. So in other words, you subtract your two y's, you subtract your two x's, but you got to make sure that the 2's go together and that the 1's go together. So in other words, whatever two parts of the point are together, that's how you keep it in order. All right. Now, the x's they already gave to us. It's the -3 and the 9. All right. So I can go ahead and write that part out. I could do 9 minus -3. All right. So that means if I wrote them as a point, I would have 9 as one of my points and -3 as the first part of another of my points. All right. Now, we need to figure out the y values. How can we do that? What have we been doing? Like, what have we been doing pretty much all this class so far? We're plugging it in for x. So we're going to take each of these numbers, plug it in for the domains, and evaluate. All right. So we're going to start with 9. So take a minute. In your head, plug in 9 into each of these domains. Which inequality is true if I plug in 9 in for x in my domains? It'll be which one? The third one? That's correct. 9 is greater than or equal to 3, so we use the third function. So, guys, heads up. Come on. It's heads up or you stand up. Your choice. So, if I have f of 9, I'm plugging that into 1/3 times 9. What is it, plus 7? Right? Or is it minus 7? Okay. Plus 7. All right. Now, what's 1/3 times 9? 3. Same thing as 9 divided by 3. All right. And then what's 3 plus 7? 10. So the point where we have an x value of 9 is 9, 10. So that means I want to put 10 here. Now we need to find where -3 fits. So going back to my domain, which of my domains, if I plug in -3 in for x, would be true? The first one, -3 is less than -2, so I'm using that first function to find the corresponding y. All right. So I'm going to find f of -3 So I'm going to plug in 5 times negative 3 minus 3. What's 5 times negative 3? Negative 15 minus 3. Negative 18. Good. So that means this point would be negative 3, negative 18. So I'm going to plug in a negative 18 here. And then we just go through and evaluate this. So what happens to these two minuses right here on the top? They can move on. Sorry, guys. They become positive. So what if we? So we now have 10 plus 8. So what's 10 plus 8? Or, sorry, 10 plus 18. Go 28. Then these also become positive because the negatives cancel each other out. So what's 9 plus 3? 12. Now, that means our average rate of change is 28 over 12, but we need to simplify it. What can I divide both the top and the bottom by to simplify? 4 is one of them. So I'm going to divide the top and the bottom by 4. You could have also picked 2. And this will be 7 over 3. And that definitely can't simplify anymore. So that's our average rate of change, 7/3. Say it one more time. Yeah. This part. All right. Any questions on that part? All right. This is the last thing that we're going to do with these notes, and then I'll give you the rest of the time to work on classwork stuff. All right. And I'll give you a 5-minute break after we finish the notes. Okay. All right. So now we're going into the graphing part. So if this is on the test, if you ever have to graph a piecewise, it'll more often be matching the graphs. All right, you may have to physically graph it, but it's not really hard. All right, it's just taking different pieces for the domain. So we're gonna graph the functions. All right. So when you're graphing piecewise, the first thing that I do is find my endpoints. All right. And my endpoints come from these x values. These x values give me my endpoints. Now, those are the x values of my endpoints. I need to find the y's. So I'm going to take each of these x values and plug them in to the function that they're connected to. All right. So for x plus 4, we're going to do x and then x plus 4, which, again, that's another name for y. All right. I'm going to do negative 2 and 2, and I'm going to leave some space just in case I need to find another point. Now, you can do this by hand or you can put it into Desmos. Either way. So if you did it by hand, all you would do is just plug it in for x respectively. So negative 2, you'd have negative 2 plus 4, which is 2. And then what's 2 plus 4? 6. All right. The other way you could have done it is you could have used Desmos. So if I open Desmos up, you can just type in the function and then generate the table. All right, so negative 2 is 2, and then 2 is 6. All right. Now, you also may want to put in one more point that is between these two. All right, because remember, if we have a compound value, that means it's between these two numbers. So I would pick one more point that's between those two numbers. So if I go back to Desmos, let's say I pick 0 because that's about halfway between them. All right. So when x is 0, y is 4. And then obviously if you plug in 0 for x, 0 plus 4 is 4. All right. Now, that's my first part. So we're going to focus firstly on graphing this first function first. Okay. Now, the other thing I need to know is what symbol is going to go on my endpoints. All right. Open circle or closed circle. And what tells me that is the inequality that's connected to them. So remember, open circle is usually next to what type of inequality signs? There's no equal to, so less than or greater than. That's open circle. Closed circle is when they have that equal to line under it. And you can make a note if you want to. Closed circle, you would see these two symbols. Open circle, you would see these two symbols. Now, on my table, I usually like to mark what type of point it'll be so I know. So for -2, 2, will that be an open or closed circle point? It'll be a closed circle because of that equal to. What about for 2, 6? Closed circle. All right. So now I'm going to take a minute and graph that part of my function. So on my graph, I got -2, 2. I'm going to make it a little bit of a bigger point so I know that's a closed circle. Well, if my computer didn't erase it. Then 0, 4. That's automatically just going to be a closed circle because it's between those two numbers. I'm going to make it smaller. And then 2, 6. All right. So that's my first part of my piecewise function. All right. Now, the second part is going to come from the second function. So we're going to do the exact same thing that we did with the first function. We're going to make a quick table. So I'm going to have x and then -3/2 x plus 9, which again, that's just another name for y. And I'm going to use the two x values in the inequality as my endpoints. All right. So I'm going to use 2. And I'm going to use 6. And then I'm going to pick one more point. So what point would you like to pick between 2 and 6? What x value? Just pick a random x value between 2 and 6. 4. All right. And again, you could have picked 5. You could have picked 3. It doesn't matter. All right. So we could plug it in for x and evaluate, but it's just easier and more accurate to do it in Desmos. So in Desmos, I'm going to put in -3/2 x, and then what is it, plus 9? Or minus 9? Plus 9. Cool. Then I'm going to generate my table. Now, they gave us the 2, so 2, 6. Then we also want to know 4, so we're going to type that in for x. And we also want to know 6, so we're going to type that in for x. So these 3 are our y values for our 3 points that we had. So I have 6, 3, 0. So we have the point 2, 6, 4, 3, 6, 0. Now, before I graph any of this, I need to decide of my endpoints whether they're open or closed circles. So for when x is 2, would that be an open or closed circle? Open. Because we have a less than symbol next to the 2. So that means it is not quite at 2. So this is going to be an open circle. 4, 3 we don't care about because it's not an endpoint. What about 6, 0? Is that going to be an open or closed circle? It's closed because the 6 is connected to a less than or equal to. So I'm going to take that and graph it over here. Now, notice how 2, 6 happens with both of our functions. So I'm just going to draw that open circle over it right now. I'll show you what to deal with that in a minute. Then I'm going to do 4, 3, and then 6, 0. And that's going to be a bigger one because it's a closed circle. And then I'm going to draw my graph. Now, if you have an open circle and closed circle on the exact same point, the closed circle dominates the open circle, meaning you do not need to draw that open circle if it's on the exact same point as a closed circle. So I can technically erase this, and this will give me my correct piecewise function graph. All right, so make a note that closed circle overrides open circle. Or you can also put beats open circle. So like if it was game of rock, paper, scissors between closed circle and open circle, closed circle would win every time. Now, this is my piecewise function. All right. So that's why it's called piecewise. It's literally different pieces of different functions over certain domains. Now, this is not the funkiest piecewise I've ever seen. This one's actually pretty tame. All right. I've seen them where they have these huge gaps in them. They're like a quadratic function and then a linear function. Like they can be a mess sometimes. All right. But in this class, the worst you'll see is a quadratic function. All right. Within your piecewise. Now, let's answer these questions. So, what is the range of my function? All right. So, range, that is what values, x or y? Those are your y values. All right. So that means I'm going to take my pencil and I'm going to find my lowest y value to my highest y value. And that'll be my range. All right. So if I'm running my pencil, what's my lowest y value at? That'll be right here. That's 0. All right. So my y value starts at 0. And I keep running my pencil along, and I'm going to stop when I run out of the graph. So what's my highest y value? 6. Good. So now, since both of those were closed circles, would I use brackets or parentheses to describe them? So it's going from 0 to 6, but would I use brackets around them or parentheses? Brackets, because both of them were defined there. They had closed circles there. Now, is this graph continuous or discontinuous? So it sounds what it literally means what it sounds like. All right. So continuous means there's no breaks, no gaps, no jumps. All right. So given the entire domain, so from -2 to +6, are there any gaps or breaks in our graph? No, there's not. So another way to think about it is that if I start from left to right and I run my pencil along it, will I ever have to pick up my pencil? No. So this is a continuous graph. So if you ever had to run your finger or pencil along it and you had to pick it up and start somewhere else, it's discontinuous. All right. Any questions on any of this? All right. So I'm going to give you your 5-minute break. When you come back, I want you guys to work on your Delta Math assignment. Because remember, don't move yet. Remember, The assignment I gave you yesterday with absolute value, it also contains your piecewise stuff. So if you look at your delta math, all right, you should now be able to do anything that says absolute value and anything that says piecewise. All right, those are the ones you should be able to do on that delta math now. And guys, make sure the AirPods are out of your ears, please. All right, so I'm gonna go ahead and start the timer, and you guys can go ahead and take your break.